Today I want to take a quick break from all this Copernicus content and build a good old-fashioned easy SOPs setup. And as a subject, I want to replicate the look from an additive manufacturing technique that I find really fascinating. 3D printing with clay instead of your typical thermoplastics. This will be my reference for today. This is a real clay print from Future Deluxe Research, and as you can see, we mostly have the same layered look as we have with our typical 3D printing techniques. There's just a lot more additional noise and chaos in those layer lines. And I especially like those droopy bits down here, and also in general how the glaze interacts with those layer lines, like this or like this. So that's our goal for today, and now let's jump into Houdini and get going. In an empty scene, let's drop down a geonode, and let's first of all create an object that we want to 3D print, in quotation marks, and in this case I want to print the good old pig head. Let's drop this down. Let's set the difficulty to easy. Let's also move it a bit, drop down a transform node. And to make this more useful as a vase, I first of all want to rotate it around the x-axis a value of -20 degrees, and I want to move it up a value of 0.7 units, like this. Then I also want to subdivide it a bit, make it a lot more smooth, and let's maybe add 2 levels of subdivision in here. And finally, since this is a 3D print and 3D prints have flat bottoms, I want to flatten this bottom in here as well. And to do so, I'm going to use a clip node, wire this in, and on this clip node set the direction to the y-axis like this. And then also check for polygons along the clipping plane like this. So this is my main model done. Now I want to turn this model into layer lines. And I'm going to take a very quick and dirty, a very lazy approach in here, which still in the end gave me good results. So to create my layer lines, I first of all want to start out with a grid. This will be later a cutting object. And I'm going to set the size of the grid, let's say, to a value of 3 by 3. This should fit our pig head like this. And then I'm also going to set the rows and the columns to 2 by 2. Just make it one single primitive. Next I want to turn this single grid and turn it into layers. So for this I'm going to drop down a copy and transform node, wire this in, and in here along the y-axis I want to specify my layer thickness, and for this layer thickness I'm going to choose a value of 0.03 like this. And then let's specify a number of copies. Let's ghost or pig head so you can see how many we need. And I don't want to fill it up completely. This, in the end, should resemble a vase of sorts. So we do need an opening at the top. And in the end, in here, I chose a value of 37. Now, the very first layer sits right on our ground plane. However, our layers will have a bit of dimension, a bit of thickness. So I want to move this layer up a bit. And I want to move it up 1/2 of our layer size or layer thickness right here. So let's quickly copy this parameter, go to a grid, to the center coordinate, and let's move it along the y-axis, this relative reference, divided by 2, like this. Now we have our object and our layers. Let's combine both of them with a boolean, turn it into actual layers. Let's wire both of them in here, and I want to set the operation to seam, like this. And now we have our layer lines in here. Let's get rid of the template flag in here. Next, I want to resample all my seam lines. Get a nice and even polygon distribution or point distribution, and again in here I want to set the segment length to the same as my layer thickness. So again, let's just copy this parameter and paste a relative reference in here, like this. Now the look that we have right now is the look of your typical 3D print. These perfect layer lines. However, again, this is not what we want for a clay 3D print. We do want a lot more chaos in here. We do want gravity to act upon all of these layer lines. And whenever we're dealing with something physical like this, it's probably a good idea to try Vellum first, because Vellum is usually a very nice tool for adding a bit more chaos into your objects. So let's try Vellum. Right now, since we're dealing with just a bunch of lines, the Vellum object that we should probably use in this case is a Vellum hair object. So let's drop down a Vellum configure hair like this. On my Vellum hair node, I want to turn on my handles tool, and I want to turn on visualize thickness. And if we zoom way in, now on each line is this little ball that indicates the thickness of my line. And right now this is way too small for my layer thickness that I'm going for here. So in my Vellum constraint properties, I want to go to the thickness tab, or the thickness parameter, and I first of all want to set this to set uniform, and then I want to specify a uniform thickness in here. And you guessed it, I'm going to base this again on my layer thickness. So again, let's first of all paste my relative reference in here. And for a perfect layer thickness, we need roughly half of this, or exactly half of this. However, I want those layers to be a bit thicker, just so my layers don't sag down as much. So to make this all work, I'm just going to multiply this by a value of 0.66, roughly 66%, and this worked nicely in the end. Let's zoom back out. I also want to quickly tweak the bend stiffness. I want to make this a tiny bit more bendy. Go down 0.0001. In the end, this is something that you can tweak to your own liking. And finally, we can drop down a Vellum solver and we can see what we get. Let's drop this down, let's wire this in, and we should also enable a ground position, and let's hit play and see what we get. And not surprisingly at all our layers currently are simply falling down and leaving this big pile, this big mess down here, which is not what we want. So we have to fix some stuff. First of all, on my Vellum solver, since we're dealing with quite a lot of collisions, I want to make those collisions more accurate. So in this case, I'm going to up the substeps, in this case to a value of 4. This will make this a bit more accurate. Also, I want to go to the forest step, and in here, I can turn up the velocity damping. The velocity damping will basically get rid of accelerations and also inertia. And I think this is a bit more accurate if we want to simulate 3D printing. So let's turn this up to the maximum. Let's turn this up to 1. And also, of course, let's increase the friction. Let's increase this both to their maximum values as well. Let's see what we get now. Let's play this. And this is falling somewhat slowly now. Let's make this a bit faster and let's again be very quick and dirty with this and simply increase the gravity, in this case to -20. Let's see what we get now. And in the end, again, we get a big pile. However, somewhere in between, somewhere around this point in our timeline, we do actually get some nice areas right here. Those drooping areas that I'm after. So how can we make those drooping areas stay? Well, in this case, I want to quickly change how we're simulating this. Right now, we're just letting all those layer lines fall all at once, but this is not how 3D printing works. 3D printing works layer by layer. And also those layers have a bit of time to dry out and solidify. And this is also something that I want to emulate in here and hopefully get the result that I'm looking for. So again, what's the naive approach here to do something like this? Well, the naive approach I'm thinking of here is with each particle-based simulation inside of Houdini, and Vellum is a particle-based simulation, we can have an attribute on our main geostream in here, an attribute called stopped. And let's quickly create this with a Popwrangle. Wire our main geo in here and wire this into the Vellum solver. And in this Popwrangle, simply set I add stopped, so an integer attribute called stopped, set this equal to 1, like this. And if this attribute is set to stopped and we simulate, none of our points are actually simulated. They're all stuck in space. And my plan in here is to simply go up a layer by layer and unstuck all my points on that layer for a certain amount of time and then make them stuck again. So basically we're simulating here, printing this layer by layer, and then also those layers drying out and staying fixed in space. So right now, everything is set to stopped. Let's now try animate this. And again, we have to animate this outside of our main Vellum solver and then bring this data into our Vellum solver. But first of all, let's animate this. And for this, again, I'm using the simple approach. I'm using a group node here. Where it's in down from a resample node. And on my group node, I want to set this to points. I want to name the group active like this. And I want to set the group by keeping it inside a bounding region. And again, I want to set the bounding box size to a value of 3 along the x and 3 along the z-axis, so that our entire footprint of a pig head is covered. But I want to make the y-axis a lot smaller. Let's maybe set this to a value of 0.2. And now the only thing that I want to do is I want to keyframe this box. I want to move this box from the bottom of a pig head to the top of a pig head over a certain number of frames. And this will be the simulation of a printing process. To do so, let's first of all, with a handles tool, move this box down so that it just does not cover any points at all. Let's make sure we're on frame number 1 and let's insert a keyframe here. And then let's say move to frame 216 and move the box up so that it again barely, just barely, does not cover any points. And again, add a keyframe. And now we have this active group traveling through our object like this. Let's bring this into our Vellum solver. Let's first of all drop down a null after a group node. Let's call this one ref for reference. And now let's jump into our Vellum solver and drop down a Popwrangle. And I want to write a very, very simple expression in here. So on this Popwrangle, I first of all want to set up my inputs. And my inputs on input 1 will be myself, the simulated geometry, and on input 2, this will be my reference. So let's pick a SOP as an input. And let's select our SOP called ref up here. And then in our code, I simply want to check if the point or the particle we're currently processing is inside that point group. So let's use the inPointGroup function. Let's look on our second input like this. We called our group active like this. And we want to check from, again, our current particle or at ptnum like this. And if this particle is inside the point group, I want to set I at stopped to 0, make it simulate. And in every other case, if it's not inside that group, I want to set I at stopped again to 1, make it stop simulating. And this is the entire code we need here. So let's wire this up. Let's jump back out and let's hit play on a simulation and see what we get. And maybe also while we're at it, let's quickly visualize this. Let's bring up our info panel and in here enable a visualizer for the stopped attribute like this. And now let's simulate this. And yeah, we have the exact effect that I'm going for here. We have our layers falling down one after the other. The unsupported layers are drooping down. But in the end, we still get something that looks 3D printed. That is not just a pile of wires on the floor. Right now, this is maybe a bit hard to see. To make this a bit easier to see, we can quickly drop down a sweep SOP. Wire our main geometry in here. Let's set the surface shape to round tube and let's set the radius to 1. And yes, this is the shape of a 3D printed vase that we got in the end. Oh, this is almost the shape. I want to do some quick tweaks in here to make this look a bit more like clay, a bit more like ceramics. And for this, I'm going to use VDBs. So first of all, once we're done with our Vellum solver in here, we want to stop simulating. For this, I'm going to use a time shift node, wire this in, and in here set the expression simply to $fand to grab the last frame in our timeline, like this. Then on some lines, we still have some openings. Now have some openings that we need to close. For this, I'm going to use an AND SOP. And I'm going to set close U to close rounded like this. And this also fills our curves, but we can ignore this. Then I want to resample this one more time. And in this case, I want to really finely resample this, because I later want to use a VDB from particles node to create our actual layer lines. So let's set this to 0.005. This gives us some really fine divisions right here. And also let's set the treat polygons as to subdivision curves, like this. Then let's actually turn this into a VDB. Let's use a VDB from particles node for this. And to make this actually work, let's turn on the voxel size. And again, let's turn those way down, again to a value of 0.005. Now to make this look more 3D printed or more like clay, I want to blend those layers together a bit. I got the most accurate results, at least in my opinion, by using a VDB reshape node for this. Let's drop down a VDB reshape SDF. And my strategy here is to first of all dilate my VDB a bit, make it a bit thicker, and then erode it, make it thinner again. And this in the end will give me some nice blended transition between those layers. Let's leave both of them at 1 voxel. This should be quite subtle. Let's also smooth this a bit. Drop down a VDB smooth SDF. Like this. And in this case, I used the mean curvature flow and I set the iterations to 2. And finally, we can turn this back into a mesh with a convert VDB node, set this to polygons, and I'm going to leave everything in here as is. Now, this is my main model done, and I just quickly want to cover just a little bit of shading in here as well. And the first thing that I want to create later for shading is also a curvature attribute. Because taking a look back at a reference, if an area is concave or convex has quite a big influence in the end on how the glaze reacts to our object. So to emulate that, I'm going to drop down a measure node. I'm going to measure the curvature of our object. And I'm going to set the element type to points. I'm going to set the measure to curvature and to mean so that concave areas will have a negative value and convex areas will have a positive value. And also I want to blur this curvature attribute a bit, so let's drop down attribute blur. Let's in here choose curvature, and 3 blurring iterations should be all that we need. So let's finally drop down a null, call this Karma, and now let's jump into Karma and Solaris and talk about rendering this. So I've got a very simple Solaris scene in here. I'm just loading in my sub object. I'm using a material library to add one material to my object, and then I also have this dome light, which uses a texture by Maxim Ross. And all I want to talk about in here is building the shader for that object. So let's jump into our material library, into our clay print material. This is your standard Karma material path, and let's turn this into a clay material. Now, your basic glaze clay is actually two materials in one. We have one base layer of burnt clay, and then on top of it we have our glaze, which is essentially just a very thin coating of glass, with some colors in there as well. So to set this up, we first of all should build our basic clay material. Now, this clay material has no metalness at all, and also it's very, very rough. Let's set the roughness in here to a value of 0.95. And to add even more roughness, I also want to add just a tiny bit of bump to the surface as well. So for this, let's jump into our node editor. Let's use a Karma Voronoi noise 3D like this. And I want to set the frequency in this case to a value right around 300. If you wire this into a base color, we can see how small those details really are. I don't want to use it inside the color though. I want to use this as a bump. Let's for now move those nodes out of the way. Let's expand the geometry tab. And let's drop down a Material X bump node. Let's wire the distance into the height. Let's set the scale to, let's say, 0.3, like this. And let's wire the out into the normal. Now we have a nice and bumpy surface. Maybe even this is a bit extreme. Let's maybe turn it down to 0.2 or maybe even something like this. And the last parameter that we need for our base clay is also some subsurface scattering. So let's bring this up as well. Let's also enlarge this here, and I want to set the subsurface amount to 1. And I want to dial this in using the scale, and I want to set the scale to a fairly low value, to a value of 0.002, like this. Next, I want to work on my glaze. This will be a coat. Let's first of all turn the amount of coat up to 1. And let's also turn down the roughness to a really, really low value. Let's maybe set this to a value of 0.01 like this. And finally, I want to bring in my curvature, and I want to color my base here based on the curvature. So for this, let's first of all drop down a geometry property value like this. We call this curvature. And again, this is a float. I'm going to quickly remap this because this is a -1-to-1 range, and we need a 0-to-1 range for what we're going to do next. And I'm going to take the output and first of all simply wire it into the base color and also the subsurface color so that we can see what we get. And as you can see, we have just a slight discoloration inside those layer lines. Let's make this a lot more pronounced. Let's add a reroute in here and let's drop down a Karma ramp parameter like this. And let's set a bunch of colors in here. On the low end, I want to have a nice blue, maybe something like this, a dark blue. Then around the middle, I want to have a lighter blue, maybe something like this. And then on the upper end, I just want to have raw clay, and I want to make this a very desaturated orange, maybe something like this. And now let's tweak the ramp so that we can get the look that we want. And I think something like this looks quite nice, where we have this deep blue down in our crevices, and those really exposed bits are just raw clay, raw ceramics in the end. Now this should also have an effect on our coating. Right here on this exposed ceramics up here, we should not see any clear coat or any glaze. This should be really rough. So we can emulate this as well by simply taking a remap value in here and remap it one more time and use this to tweak our code. I'll wire this in here. And I sort of want to match my ramp up here. So let's first of all select our middle value in here and copy this position and paste it in our in low. And let's grab our clay color in here, copy this position and paste it into our in high in here. And if we now take our output from here and wire this into our code, which we do need to expand like this, our exposed clay bits right here are also nice and rough now. And the last thing that I want to add in here is I want to bring back my Voronoi noise down here, make this affect our color as well, at least a tiny bit. And everything I want to do in here is basically just remap this Voronoi noise in here as well, and then multiply it with our color. So drop down our last remap node, let's wire this in, And let's set the out low to a value of 0.5 and the out high to a value of 1. And then drop down a multiply node. Let's wire this into our color. And in the second input goes a Voronoi noise. And now we have this nice noise pattern also in our color, in our glaze, which is exactly what we want. So this is what I'd say is the bare minimum for a ceramics material, or a glazed clay material. You can get a lot more fancy with this, you can add a lot more noises in, make the color ramp a lot more complex, and maybe also start tweaking, for example, the metalness of the glaze, because there are some glazes out there that can leave a really metallic finish. You can go wild in here, create really beautiful results. However, this is where I'm leaving this for today. And until next time, it's cheers and goodbye. And if you like us and want to support us, or just simply want to learn more about Houdini in in-depth courses, consider becoming a patron of ours. And to everyone already supporting us, thanks so much. Without you, Antagma in this form would not be possible. Thank you.